Welcome to the channel. Today's tutorial is on solving one-step algebra equations. And you can see here that I've written a very basic algebra equation, x plus 9 equals 12. Basic terminology, the letter in an algebra equation is always called a variable. You can choose to use any letter from the alphabet, A through Z. It doesn't matter which one you choose. In this case, I've chosen to use x. The goal of algebra and solving one-step equations is to do something called isolating the variable, which means I'm trying to get the variable on one side of the equation all by itself, and I'm trying to get all the numbers onto the opposite side of the equation. In order to do that, I'm going to use something called opposite operations. An opposite operation undoes another operation. So I can use subtraction and addition, and I can use multiplication and division. And what I use depends on what operation is being used in the equation I'm trying to solve. In this case, I have the operation of addition. So in order to solve this equation and to isolate the variable, I would choose to use the opposite operation of subtraction. Let me demonstrate then how to solve this equation, x plus 9 equals 12. So as I said, I'm going to choose the opposite of adding, which is subtracting. So I'm going to subtract 9 from this side of the equation. And if I have positive 9 subtract 9, those cancel each other out. The rule in solving all algebra equations is that you need to balance out the equation. What that means is, whatever I do on one side of the equal sign, I then need to go across and do the same thing on the opposite side of the equal sign. So I need to subtract 9 from this side as well. I can now rewrite this. On this side of the equation, I'm left with x, and 12 subtract 9 is 3. I can then go back and verify to see if I have solved this correctly. I've just said that x is equal to 3. So if I go back to my original equation and put a 3 in where the x is, 3 plus 9 equals 12, I then know that I have solved it correctly. Let me show you another one here, and demonstrate again how to solve this. The operation that I have in this question is subtracting. The opposite of subtracting is adding. So I'm going to add 8 over here, and that cancels those out. And if I add 8 over there, I have to add 8 over on the opposite side of the equation to balance it out. I can rewrite this now. Y is by itself over here, and negative 5 plus 8 makes 3. And again, I can verify this and go back. I've said that y is equal to 3. If I take this 3 and put it over here where the y is, 3 subtract 8 makes negative 5. I know that I've then solved it correctly. Here's another question I'd like to show you. It's a little twist to this one. You'll notice that the variable is on the opposite side of the equal sign than the previous two questions. It doesn't matter. All that you need to remember is I always start on the side that has the variable, and I'm going to then try to remove this 9. This 9 doesn't have a sign in front of it. That means it's positive. It's a positive 9. So the opposite of a positive 9 is a negative 9. So I'm going to subtract 9 from this side. And if I subtract, that's cancel those out. And if I subtract 9 from that side, I have to subtract 9 from this side. And now I can rewrite this. On this side, I have m by itself. And 15 subtract 9 is 6. I usually like to write these with the variable first. I typically write it as m equals 6. Let me try one more for you. Here we have negative 7 equals t subtract 8. I'm going to start on this side, and the opposite of subtracting is adding. So I'm going to add 8 on this side, and therefore I have to add 8 on this side. These 8s are canceled out, and I can now rewrite this as it's going to be positive 1 equals t. And I would typically rewrite that as t equals 1. At this point in the tutorial, I'd like you to try these two questions. X plus 24 equals 30 and negative 12 equals t subtract 10. Compare your answers with mine once you are finished. X plus 24 equals 30. The opposite of adding is subtracting. So I'm going to subtract 24 from this side, cancel all the 24s, and then I'm going to subtract 24 from this side. And I can rewrite this as x equals 6. For the other question, I'm going to start on this side. The opposite of subtracting 10 is adding 10. And if I subtract 10 on this side, so those cancel each other out, I'm going to have to add 10 on this side. I can rewrite this. I'm just going to put the variable first. t equals, and negative 12 plus 10 makes negative 2.
The questions that we have been solving up to this point have involved the opposite operations of adding and subtracting. Here you can see that you have a number touching a variable with no sign in between. That means multiplication when we are working with algebra. So to solve this, we do have to choose the opposite of operation of division. So for this question, in order to remove this 7, I'm going to divide by 7. And this line means divide. That cancels out these 7s. And if I divide by 7 on that side of the equation, I need to divide by 7 on this side of the equation. And I would say that x is equal to 14 divided by 7, which is 2. Let me bring another question out here for you to try. So here we have 25 equals negative 5y, which means negative 5 times y. The opposite of multiplying is dividing. So I'm going to divide this side by negative 5. Therefore, I have to divide this side by negative 5 as well. These negative 5s cancel each other out, and I can rewrite this as y is equal to 25 divided by negative 5 is negative 5. Here's another question. In this question, you'll see that we have x over negative 9 equals 2. When you have this line here means divide, so this means x is being divided by negative 9 and it equals 2. So the opposite of dividing is multiplying. And when we're working with algebra, we're going to use this little dot to symbolize multiplication. So this means times negative 9. Opposite of dividing is multiplying. So we're going to multiply to get rid of these negative 9s. Therefore, I have to go across the equation and multiply by negative 9 here as well. And I can rewrite this as x is equal to negative 18 because 2 times negative 9 is negative 18. Let's try one more. In this case, we have negative 4 equals x divided by negative 5. So again, I'm going to use opposite operations. The opposite of dividing is multiplying. So I'm going to multiply by negative 5 on this side, and therefore I have to multiply by negative 5 on the opposite side as well. I could rewrite this as x is equal to negative 5 times negative 4 makes positive 20. I'd like you to pause the tutorial at this point and try these two questions on your own. So in this question, we have negative 7 equals x divided by 10. So if I'm choosing opposite operations, the opposite of dividing is multiplying. So I'm going to multiply this side by positive 10. That'll cancel these 10s out. And therefore, I'm going to multiply this side by positive 10. And I'm going to rewrite this as x is equal to negative 70 because 10 times negative 7 makes negative 70. In the other question, we have negative 6 times x equals negative 36. So the opposite of multiplying is dividing. So I'm going to divide this by negative 6 to cancel those 6's out. And therefore, I'm going to divide this side also by negative 6. And I can rewrite this as x is equal to 6.